Hi, this video is primarily for my electrical students. I've got an older Cadillac here and the battery goes dead after a couple of days of non-driving. So what I've got set up here is a parasitic drain test. I'm using a DVOM and I've got right there a connected negative cable. I have an inductive ammeter or amp probe connected. The probe is set up so that every 100 millivolts or 0.1 volt is equal to 1 amp. Now what I'm seeing here is from time to time this rises and then falls. There we go. Looked like it ran just under 4 amps there, but it was at its peak. Now this is pulsing up and down. So what I'm going to do with this meter, I'm going to go ahead and do the min-max and actually a peak min-max to see what my maximum values are, and we'll see then what's going on. So I'll go ahead, min-max, peak min-max. Whoa. Now, as we saw right there, that is 11 amps peak. So this thing has quite a bit of an amperage drain. And again, it's pulsed, it's not continuous. So it's going up and down and up and down. So something is either being commanded up and down, or something itself has just got a mind of its own, is it doing it on its own. So let's see what our minimum is, negative 0.03. That would be actually 300 milliamps there in the negative direction. So it's possible either my zero is skewed a little bit, or maybe I've got a motor or something that's going on here and actually providing a little bit of AC voltage or voltage in the negative direction. The other possibility could be a solenoid that is pulsing on and off. Could give me, again, a voltage reading in the negative direction. I don't know what kind of solenoids are on here other than maybe the starter that's going to be pulling about 11 amps though. Next, I'm going to go ahead and probably just put a current probe using the scope on, again, the negative cable. Here's the current trace for the parasitic drain. We've got an increase of current occurring here. There we go. It's increasing. That was up over 10 amps. The pattern appears to be that of a brushless motor. Regardless, we'll look at this. I believe we've confirmed our parasitic drain here, matching the peak min-max of the meter. I've already pulled the fuses and I know which one is causing the draw, so I'll just go ahead and show you that. It happened to be the fourth one down here. It's 50 amp fuse. Pull him out of there if I can. Alright, amperage went down. Now let's take a look. At fourth fuse down is the inadvertent fuse right there, the maxi fuse. Wiring schematic now showing me that that inadvertent fuse is going to power up the blower motor, but it's also going to another power distribution, and that happens to be the inadvertent relay. Now, inadvertent relay, after a period of time, it is going to turn off certain accessories, lights, things like that, so it doesn't kill the battery. So what I'm going to do, if we look here, the inadvertent relay is right here. So I'm going to go ahead and disconnect that inadvertent relay. We're going to attempt to anyways, maybe, if this cooperates. All right. Now before I do that, we'll plug the fuse back in. Alright, fuse is plugged back in, and we see the drains going on there. Okay, So I'm going to disconnect or unplug that inadvertent relay, and we'll see if that continues on. So with the inadvertent relay removed, that should have taken out a whole bunch of lighting, things like that would be on. And it appears that I still have the drain. Watch it. Yep, there it goes. So that's telling me that it does happen to be that blower motor. So we need to take a look at the schematic and see whether the blower motor itself is doing it or whether something else is commanding it up or down. This particular motor has a controller built into it. This is not a brush type motor, it's a brushless motor, so it needs a controller to actually make it do its thing. So that's going directly into there. Now the other thing that I have highlighted in blue, that is the speed control coming from what General Motors is calling their HVAC programmer. All right, so if we follow that, there it goes. It goes into the blower speed control. And again, that is, see if we can see that a little bit. Maybe it'll focus. There we go, heater and AC programmer. I need to determine whether it is being commanded up and down by the programmer or whether the blower motor control module itself is simply pulsing the blower motor. So I've got a DVOM plugged in to the gray wire, the blower speed control wire, and I'm looking at voltage right. I believe that signal is pulse width modulated, or it might even be frequency modulated. I don't know for sure on this old beast. So I'm going to check to see if there is a frequency or if there's pulse width. So I'll go ahead and set the meter up for that. All right, it's showing 0 hertz. Well, for a percent duty cycle. So I'm not sure at this point whether the voltage that we're reading there is actually coming from the motor or the motor controller there, or whether it's coming from the programmer. Now, one thing I'm going to attempt to do to maybe isolate the programmer, if this doesn't work, well, then maybe I'll remove some wires or cut some wires or something. If we take a look at my programmer, all right, that red wire I have highlighted is battery voltage. It's coming from the comfort fuse, and that's located in the rear fuse block. So what I want to do is remove that and see if this thing stops pulsing. If it stops pulsing, then that suggests that the programmer is actually controlling this speed up and speed down of the blower motor. So before I do that though, what I want to do is set my scope up. All right, scope's now connected. The top or the blue line is the voltage at the speed control of the blower motor. And the red trace, or the bottom line there, is the current there at the battery. Next thing, I need to, again, to try to determine whether or not that voltage on the blower speed control is coming from the programmer or not. Now, I can open the wire, the speed control, either at the blower motor here or back at the programmer. Or what I'm going to try, it's a little easier, I'm going to unplug the fuse that is the battery hot on that programmer. And hopefully we'll find something this way. So I'm going to go back and attempt to pull that fuse. It appears to still be pulsing somewhat. Oh, there it goes. We're still climbing up over 10, probably 11 or better amps. All right, so I'm going to look more at the blower motor as the culprit here. I think I will go ahead and just disconnect the blower speed wire here at the blower motor. We'll just depin it from the connector and see if we still get this going on. All right, I depinned the connector. And I did what I did not want to do. I know a lot of times guys will simply snip a wire and then repair it later to see if they fixed the problem. I don't particularly care for that, at least not teaching it. Real world, it happens all the time, but I had to do it mostly because this type of connector has the stupid terminals come out from the front. It doesn't come out from the back. So in order for me to remove the wire to isolate it from the circuit, I had to cut it. So anyways, there it is. Now I'm going to go ahead and plug the connector back into the blower motor without that speed control wire, and we'll see if the drain is still there. All right, the drain is still there, the current. Now, I'm going to go ahead and reconnect the blue channel to that speed control wire that I've cut coming from the programmer. We'll see if we've got anything going on there. All right, it is connected to the wire coming from the programmer, and we've got a nice straight zero line, so that programmer's not doing anything. All of the voltage, all of the current that we're seeing is coming from this blower motor itself, or the controller that's an integral part of it. So the reason I went to this length to diagnose it is because the retail for at least the OE part, the Delco part, is somewhere in the neighborhood of $450 for that. So I wanted to check to make sure that absolutely there was no doubt that the blower motor is at fault here. And there it is. So I'll go ahead and replace the blower motor once I get the part, and that'll fix the situation. We'll no longer have any kind of battery drain with the blower motor plugged in. So that's all I have for now. Thanks for watching.